Hi, welcome to day 7 of the Common Lisp series. So today's objective in the original was to create a Hangman game. But before we go there, we'll see a few more loop variants. So we've already seen things like do, collect, for, ranges, and so on. We also seen repeat. So today we'll start with something else. So the next variant is just looping over items of a list, right? This is very common. So if I do something like this, we can collect it back, but that does not make so much sense. So let me just do something like print, and so this works. So what you're seeing is you're just looping over the elements of the list and printing each of them, right? I in list. So if you want to do the same thing with arrays, so if I make this becomes an array, not a list. But this syntax doesn't work. So if I run this, we will have an error, and the error is that this is not a list. So we can just abort this and let's go back. If we want to loop over an array, the simple variant is across. So instead of using in, you just use across. So if you do this, you get the same thing as before. We are going I across the elements of the array. So this is yet another variant of using loop. Now that we've done this, let's look at another interesting angle here. And that is actually using multiple of these verbs. So if I take the same example below, I have used a do and an expression after that which will run, but I can also do something else. So I can also say collect I, or let's say we want to do 2 into I, right? So if I do this, so what we're doing here is we have a do section with an expression and we have a collect section with an expression, and both of this will run. So the do block will run and print I for each of the elements of this array, and then we collect this expression, which is I into 2, for each of these elements, and that returns a list. So this is a list, though this input was an array, right? But the interesting thing here is that you can actually use multiple verbs. So for example, if I just convert this into another collect and this into just I. So since you have two collects, they will actually collect the results back into the single list that we have seen before. So if you do this, we are actually going through this 1 and 2 are collected, and then for 2 and 4 and so on. So all that each of the collects is run for each of the elements, and then we keep proceeding. So this is the use of multiple verbs in a single loop expression. Now let's also look at an interesting angle of if, basically selection. So I have an example here which I will go through, but you can see it here. So let's start by making an array. So we'll have an array with 10 elements. It can also be a list, but I'm just using array here. Then the simplest way to initialize this, right? So loop I from 0 below. So here we're using length of the array 10. So 0 below 10 would be 0 to 9 inclusive. And then we do this expression, which is a set f with that ith element set to a random number, right? So if we run these, we are going to get some random elements. Now in this third expression, what we're doing is we are doing the same loop again on the same array, but this time we have an if condition, and the idea is only for those elements where this condition matches, we actually have the subsequent verbs executed. And in this case, I've actually done kind of overloaded that verb of count, where I'm also actually doing some expression for side effect. So basically what we're doing here is we're doing a set f of this ith element to 0, and that's the side effect. So those elements which are below 5 would not be set to 0, but we also count these aspects. So you also know how many elements are below 5. Let's just take a simpler example. Let's just do something much simpler than that. So let's say for I in, and let's have a list here that we construct, and okay, so in this case let's add an if condition, right? And we can put any expression here. So for example, if we say let's say basically check if the number is even. So because you have said I, and then we want to check if the number is even. And if that's the case, let's say, let's collect, right? Let's just start with something simple. Right? Let's just collect it. So that gives us all the even numbers out of this list. But you could have say, okay, instead of collect, let's say you want to count, right? So you could have done this. And that's 3. Now, obviously, you can do these things in a more functional manner, but in this case, I'm just showing how loop can be used for these scenarios. So with this done, we can actually go to our hangman function. There's a bunch of things happening here. Let's go step by step. So first we start with an outer level let to have some constants and things that we want to use. So in this case, I'm setting the number of lives to 7, for example. I'm just hard coding a word here for simplicity. Ideally, you should have some random word generation here, but let's do that later. And I'm going to create this mask. So the way I'm approaching this is I'm going to create a mask, which is a bit array, right, of that same length of the input word. So what we're seeing here is this make array, and we're setting the element type to bit so that we get a bit array. And we're just going to create this mask, and by default it's all going to be 0 unset. And we'll use this mask to track what letters have been guessed correctly, right? So now within this let star, so the way when I wrote this code, I started with this let star, and then I immediately go to the inner body of this function, right? But then when writing the code, you realize you need some things, you need some helper functions, and it's simpler to show the logic in one place. So I've moved those functions out into an flet. And that becomes more clearer if I show this coding process. But for now, just let's just go with this top-down approach. So here I have a function to prompt, which we will call in rounds, in iterations. And we are just first going to print the word that is so far, right, that the user has created as guessed so far. So for that, we have this loop where what we are doing is, like we saw before, we have two variables running across two different arrays. So we have this string word, which is also an array of characters, like I mentioned. So that's why we have I across word. And we also have the another variable j iterating across the mask. So that's the bits representing whether that letter has been guessed or not. And then we have the simple do block, where what we're saying is, if the particular mask element j here is equal to 0, then we'll just return blank. That's the user doesn't know this word letter yet. Or if not, we will simply get the I character of the word and return that. So this way, basically what we're doing is we're just printing. Here I'm just printing each of these characters as we loop, but you could think about doing it differently, right? You could collect those letters and then make a string and then print that string one shot, right? That is also okay. So this is our prompt function, and we'll use this prompt function in rounds. Once the user prompts, we'll then have a guess, and then we have to validate the guess, right? But let's look at the main loop. And here we see yet another use of the loop macro. We have a loop, and instead of a for, instead of for in, for, from, for across, we have a while. And this is like more like a typical while loop that we have. So here we're just having a check expression that will be executed every time. And while it's true, the body will not the body. In this case, there's a do condition. You could always have a collect or something, right? So now this is a very stateful, very imperative way of doing things, right? We are going to basically have to manipulate this num lives variable ourselves in the do block, because otherwise it's not going to change. Unlike the previous examples where we are looping I or j, where the loop macro is the one that is looping, right? So instead here it's very manual way where we are going to ourselves change this variable. So let's see the do block. One more interesting thing here is I have not used a progen block within a do, because all the do the expressions after do in the loop top level are considered a body of the do, right? So we have multiple expressions here, but they'll all run in sequence. that there is an implicit program here. Okay. So we are first calling the prompt function, which will simply print the word that we have so far. Initially, it will all be blanks. Then we have this simple print to basically new line and then just say how many lives we have so far and ask prompt for the guess, right? And this is the same thing we've done before. I'm using read line to get a string, but we just want one character. Basically, user enters a character and hits enter, and we have that character. And then I'm going to actually go through pauses to the guess function. So let's look at the guess function above. So this is basically a user attempting a guess and with that character. And let's see, again, this is yet another loop we are doing here. Let's see what this is. So we are saying loop I from 0 below limit of word, straightforward, each character of the word. And now what we're saying is, I have done here I because we'll see why I have done this. And then we again check if that character, looking at the character basically like this, ith element of the word. I could have done here for I across word like we did here, right? But then that won't allow us to actually do a setf, right? The example I showed before, where we also want the side effect of the loop. So what we're saying is we're looking at all the places because a single guess, a single letter can occur in multiple places in the word. So here we want to run this body for every match, every character where it's matching, and then we do a count while also doing the side effect, right? So we are getting two things here. So the part of this body, we are actually going to set the mask to 1. So wherever there's a match for that letter, that ith bit in the bit mask will be now set to 1. And we also return the count, right? So we are doing two different things in this one loop. And if you see here, when we guess, we get that count back. And if that count is 0, so that basically means that that letter was not there, not present at all in that word, which means we get to decrement the num lives variable, right? So it's basically a bad guess. User has lost a life and you decrement it, right? And so basically here then we just have a simple check to see if every element of the bit mask is now equal to 1, right? So basically this every function is one of those sequence functions that you can run. So every takes a lambda and then the sequence, right? In this case it's a vector, it's an array, the bit mask, and we check if every element here is equal to 1. Actually, if every element matches this condition, and this condition is we are checking for equal to 1, and if that's the case, there is game over. So you can just end the loop and return directly from this function, or else you just keep looping until you reach number of lives equal to 0 or less than 0, right? In which case it breaks out and it goes to this statement here where it's just printing that you lose.